Today we're going to work on some math problems. We're going to do some basic series circuits to start with, and just do a few practice ones. We've already subjected you to the Ohm's law. We've done the EIR and the PIE, and we're going to use those, and we're just going to draw some problems. Now, it's been my experience that most people typically do better when they draw them, and when the circuits can get complicated and get drawn kind of weird, if you redraw it a lot of times, that will help you to get it right, get the right answers. So we're going to try a couple and see how it goes and do some basic problems. So let's start out. We'll do with a total voltage of 110 volts. And then we're going to do voltage ER1. We'll do equals 40 volts. Probably put an equals there so you can see it. 40 volts. And then ER2 equals, we don't know. So we've got 110 volts, 140 volts. Now I'm going to draw this circuit. Of course, this is would be a very simple circuit once you get started, but this would really look like maybe like this. And as you get into more complex circuits, it's going to help you to draw them out. So this is ER. ER1. And that's 40 volts. This is ER2. And that equals, we don't know yet. And this is ET, which equals 110 volts. All right, so we're going to start talking about some of the rules when you're talking about circuits. One of the rules that we know is that when you're in a series circuit, for one thing, there's only one path of current flow. One path. So all the current has to flow through everything. It's got nowhere else to go. Another thing we know is that our voltage, this voltage 110, has to drop all the voltage in each path. So no matter if we have multiple paths, all the voltage has to be dropped in each path. So if we're dropping 40 volts across this resistor, that means if I measured across that with a meter, I get 40 volts. That's what that's dropping. Should be a V. All right. Our total's 110, so that leaves that this has to be 70 volts. So that's the way you would solve that. That have to be 70 volts. All right, so if it was 1 amp, put 1 amp there. If that's 1 amp, that means this has to be 1 amp, and that means that has to be 1 amp. There's nowhere else for that amp of current to go. If it flows through here, it's got to flow through there. It's got to flow through there. It has to. There's nowhere else for it to go. All right, and then what about resistance? Well, let's do our little charts over here. We could do that. EIR and PIE. So let's solve this. So this is pretty easy, right? So 70 volts. We're looking for R. So E divided by I, right? So 70 divided by 1 is 70 ohms. Same thing with 40. 40 divided by 1 is 40 ohms. And our total resistance over here, this is IT, by the way. And our RT total would be 110 divided by 1. 110 ohms. Also notice that your resistance In a series circuit, all your resistors will add up to be the total resistance. So your voltage will add up to be the total, and your resistance will add up to be the total. Now your current, it won't. It'll be the same everywhere. So that's the difference with the current. It'll be the same no matter where you're at. Now what about power? So if we're looking at power, P is I times E, right? So I times E. So 70 times 1 is 70, and that would be in watts because that's power. 40 times 1 would be 40 watts. 110 times 1 is 110 watts. Notice also your watts, of course, will add up. Your total watts in your circuit will add up to be the total. And your watts, even in parallel circuits, will add up to be total. But we're going to have to be careful. Some of the rules change when you do parallel circuits. Some of our rules are going to be a little different. So let's do another one here, and then maybe we'll do a parallel. So let's do another one. Maybe do 3. So this is ER1, ER2, ER3, and that'd be IR3, IR2, IR1 equals twice enough. This would be ET, IT, RT, and power T. So what we did R1, IR1, and R1, R2, R3, P3, P2, P1. Alright, so we just get some different numbers here. See if I got something. I'll do this one. So this one here is 24 volts. And a lot of times I circle them when it's given. Hopefully you can see that okay. And this one is 3 volts. That way I know which ones I started with in case there might be something bad happens. IR2 is going to be 3 amps. And R3 is 3 ohms. Alright, and there we're ready to work. Alright, so we're probably going to start needing our calculator pretty soon. So let's go ahead and we'll start using that a little bit. I have a trailer that I'm going to put on, upload here soon, hopefully. And it shows the book and the calculator that I use a lot. It'll cover most of our theory videos that we're going to be doing. This will do them all. So, little simple calculator. And I'll give you a picture and everything about it later. So for right now, let's solve this circuit. So let's look at this and kind of get an idea of what's going on. So this is a series circuit. So there's only one path for current flow. See right here? It's got 3 amps in that current right there. So if I got 3 amps, if I have 3 amps flowing there, I have 3 amps flowing here. I have 3 amps flowing here. I have, I'm kind of tight there. 3 amps there. Okay. So then, now once I have two things, then I can solve everything in that group. Now this one I don't have two things yet, but I can get two things after a while. So let's just get started. So let's just start with the totals. We have current and we have voltage. So let me see, I have current and I have voltage. So E divided by I is going to equal R. So E, 24, divided by 3 equals 8 ohms for R. 8 ohms. All right, and then P, we need P, so put your thumb over to P. I times E equals P. So we'll just do I times E. 3 times 24. Now give me my total power, which is 72 watts. I should give myself a little bit more room over there, but that's all right. We'll manage. I'm used to a great big board. All right, so here we have voltage and current. So we have voltage and current. We could get power, or we could get R. So let's get R. Well, we'll get power. I times E. Why not? 3 times 3. We don't even need a calculator, do we? 9, and that would be in watts. That's power. 3 times 3. And then 3 divided by 3, give her resistance. 1 ohm. It's not much resistance, is it? Of course, we only have 8 total, so we're going to see how that works out for us. Okay, so let's solve this one down here. We'll save that one till last. So we have 3 amps and 3 ohms. So current times resistance will equal voltage. So 3 times 3 would be 9 volts. And then 9 times 3 would be 27 watts. So for watt, power is I times E, right? So I times E. 3 times 9 is 27 watts. All right, so now there's a couple of ways we can do this. Actually, there's multiple ways to work these problems. Ohm's law always works. So you'll see that as long as you do everything, you follow the rules, it always works out, and you can check yourself with another formula. So remember I told you the law that in a series circuit, all the voltages had to add up. And then in any circuit, all the powers have to add up to the total. So we could do power. Let's do power. Power is always a good choice because there's some rules that are going to affect when we get in parallel. Some of this other stuff's going to change, but power's going to stay the same. It's still going to work out for you on this. So 72 minus 9 minus 27 equals 36. Do them all. 36 watts. Let's check. 50, 63, 72. That should be it. And then 36, we have watts and current, so power in amps. Power divided by amps equals voltage. So 36, well, we got that, have that in the calculator, divided by 3, give us 12 volts. And then for resistance, we cover up the R, E divided by I. So that's 12. I have that in my calculator, divided by 3. And it gives me 4 ohms. Now on a series circuit like this, all your resistances are going to add up too. So you can check yourself there. 3, 7, 8. Total is 8. You can check your watts. All the watts add up to 72. The current is the same in all of them. All the voltages add up to 24. 3, 15, 24. So you can double check yourself like that and make sure that you got all the circuits right pretty easily. And that's a series circuit. One other thing I did want to show you, and I should have done it on that one probably. We'll do one more. How about that? We'll just do one more. So let's do one more series circuit up here. And I'm going to do one like this. We may talk about these a little bit. Oh, I need a ruler. Can't make a straight line with a ruler anyway. All right, so there's the circuit we're going to do, and we're going to start with 36 volts ET. Let me fix that. I can do it a little better than that. Let's do it in here. ET equals 36 volts. Alright, and R1 is 5 ohms. 5 ohms. And we'll circle those. And R2 is 7 ohms. And R3 is 6 ohms. Okay, so we need ET, IT, RT, and PT. We need ER1, IR1, and PR1. ER2, IR2, PR2, ER3, IR3, PR3. Okay, so now we're ready to start. So we have all these resistors. Now remember, resistors in series, you've got this resistance, this resistance, this resistance. So they just add together, and that'll be the total resistance. So that makes that pretty easy. So you've got 18 ohms. 5, 7, 12, and 18. So you have 18 ohms. So now you have two things here, so you can figure out the rest, right? So that's how it works. 36, let's see, we have voltage and resistance. Voltage and resistance. Voltage divided by resistance will give us the current. So 36 divided by 18. And you don't really need a calculator for that, but better to use it. Sometimes the simple mistakes get you. So 2 amps. So if I have 2 amps flowing through here, it's got to flow through there. It has to flow through here. It's got nowhere else to go. It's only a one path thing going here. So it's got to go through all that. So now we have enough. Let's go ahead and solve this while we're here. The power is P is I times E. So I times E. So that would be what, 72 watts. And then current times resistance equals voltage. Put your finger over the E. I times R. So I times R. So that would be 10 volts. And then P is I times E. So I times E would be 20 watts. All right, then we have I and R again. So I times R equals E. 14 volts. And 14 volt. Cover up the P. I times E equals P. So that would be 28 watts. 28 watts. Well, that's the right little thing in it. Look at that, 28 watts. And then let's see, we have I and R again. So I times R equals E. So that'd be 12 volts. And E times I. No, wait a minute. P is I times E equals P. That'd be 24 watts. Okay. So now we check ourselves. 24 and 24 is, or 24 and 28 is 52, plus 20 is 72. 72 watts. That's good. Our ohms, 6, 13, 18. We already did that. 2 amps all the way through. That's good. Now check our voltage. We have 12 volts. 14 volts is 26, plus 10 is 36. 36. So I'm saying that that all worked out for us. That all looks right. You can double check yourself with Ohm's law, and Ohm's law always works as long as you do it right. The next thing I wanted to show you, if you took your, we call these voltage dividers a lot of times, series resistance circles. You may hear that term, voltage divider. So if I took my voltage off, let me get the other pencil. If I took voltage off from, let's say, here to a meter, I would read 10 volts. If I took voltage off here to a meter, I would read 7 volts. If I took voltage from here, I would get 10. Whoops, that's not 7, is it? Read my own right, 14 volts. So I get 10 volts from there. I can get 14 volts from here. And I go ahead and do this one while I'm here. How much would I get here? 12 volts, right? And from, if I went across both of these, I could get 24 volts. Of course, if I went across here, I would get, 36, but that's why we call it a voltage divider. We can get all different voltages off of this. We could come off of here and here, see? And you would get, what is that, 14 and 26 volts. So that's why it's called a voltage divider. When you're in series, when you do resistances in series, you can make any kind of voltage you want. And just by how you do your resistors, and you can take any different kind of voltage there. And we use that technique sometimes for different types of circuits. And I just want you to see that. So that's it for the series, and I think next time we'll do parallel.